Thanks everyone for braving the cold this morning. Thanks for coming to listen to us talk about storm management and infrastructure design. This is part of a continued series that the IPRC and ACEC has been working together on. Erin helped develop most of the content for this, so she's up here as being recognized. I want to start with introducing my team. This is the Storm Management Development Services team. Saifuddin, Jeanette, Erin, Robin, and Ron. Steve Mason's out sick today. We've got some announcements and some reminders, just some general information to go through. And then we'll get to some design standards and some examples of those design standards being either successfully or unsuccessfully applied. So our announcements and reminders, we're going to just mention the maintenance agreement fee that was made effective October 1st. We'll talk about submission of floodplain development permits, fire storm management plans need to be submitted 7 days before pre-sub. TRWD has recently introduced a water quality guidance document, so I just want to bring your attention to that. If you happen to interact with TRWD, maybe you have an outfall through the levees, then you're going to need to be aware of that. We have plans to move some of our permitting activity to a cellar. We'll build on the success of IPRC and their shift to a cellar. We also want to mention the potential update in 2019 for our Stormwater Criteria Manual, and just let you know that the NOAA Atlas for Texas has been published. So the new maintenance agreement recording fee is $635. You need to bring a check made out to the City of Fort Worth with the 3 original hard copies that you submit to the Planning and Development Department. We'll continue to provide review of the electronic exhibits ahead of time to try and make sure that when you actually get to the point where you have to record your maintenance agreement, it moves smoothly. There is a procedure and a guide available online. Make sure you write down that link. If you have any questions, you can email us at the swifma@fortworthtexas.gov. So about the middle of August, late August, the Stormwater Development Services Group started receiving or accepting the ISWIM as well as the floodplain development permit. Previously, you had to submit all your floodplain development permits hard copy to the floodplain team. As of August 20, you can email it to us at STS, or you can send us a link to download it or upload it to Buzzsaw the same way you would an ISWIM plan. At least the processing and submittal process should look and feel like a stormwater management plan. So we're basically going electronic with the floodplain development permit at this point. It's being tracked the same way that we track stormwater management plans. I did want to just touch on how those two submittals come in. Make sure you don't combine them in the same PDF. If, for example, the floodplain development permit is an appendix to the ISWIM plan, our text won't catch that, so you might end up delaying yourself by not making it clear that they're two separate submittals. It just comes to the same team now. As of October 1st, I think, actually let me back up a little bit. So there was a group of people that were getting together to talk about the infrastructure delivery process. So all of the developer-led infrastructure improvements. There's been an ongoing coordination, I think a Six Sigma project, to find improvements and compress the time frame in which you can get in and out and get to construction. One of the items that came out of that was having the preliminary storm management plan accepted and the final storm management plan submitted 7 days before pre-sub. Previously, it was just the preliminary storm management plan, and then you could move on to pre-sub. But the way it's working now, and we've been giving a bit of a grace period, so you probably have received a reminder if you haven't met that criteria. So from here on out, it'll work, more like this. So accepted preliminary and a final submitted 7 days before pre-sub. And the idea here is that if the timing works out, then you'll actually end up with pre-sub comments and final item plan comments about the same time. It also allows us opportunity to take a look at any updated models or additional information that's in the final and provide a more informed review of your infrastructure plans. Hopefully what this means is less compliance reviews at the end of the process and a faster route to construction. So if the timeline that I kind of sketched out there was a little confusing, the main takeaway is that preliminary needs to be accepted and final needs to be submitted 7 days before IPRC pre-sub. That's the main shift. Everything else, all the other links between storm management plans and infrastructure plans remains the same. Part of that process shift, I also hope, means that we can draw a better distinction between infrastructure plan review and storm management plan review. What we often see is a complete civil set submitted with the final item plan. But if we're reviewing your final item plan and your infrastructure plan set, we don't need to be doing 2 reviews. You don't need 2 sets of comments. So as best we're able to, we'd like to see the construction plans move through IPRC and more of the H&H modelling, more of the concepts and the exhibits in the item plan, if that helps. So the Tarrant Regional Water District has published their stormwater, their water quality guidelines. I just wanted you to be aware of this because they've made a shift from grey infrastructure, things like storm scepter units, to green infrastructure. And so when you're laying out your project site, you need to consider that green infrastructure, those bioswales or those other elements as part of your early site planning work. If you have any questions about the TRB water quality requirements, there is the guidance document, but you can also contact Brenton Dunn with TRWD. That's just a map of their area of authority, their jurisdiction. And so it's primarily confined to the federal floodway projects, as well as Panther Island. It's a little hard to see on these maps, but the red dot there is Panther Island, and TRWE, or TRVA, is reviewing and working with most of those customers. There's a general process for just their water quality review. I know some of you probably have other questions about permitting new outfalls and that overall process, but just for the water quality review, they would like to see that you submit a concept plan, just a site plan with your location of your green infrastructure, and then work with them to find consensus on that concept plan. Once you get to that point, agree on a concept, move forward to the detailed design calculations. They, of course, need to be signed and sealed by a PE. You might need to work with the landscape architect to refine some of that design. Once you reach approval of the design, obviously they issue your permit as long as everything else is in place. But once the permit's issued, you still need to go back and submit a report confirming that the construction was done in compliance with the approved plans. If you have any questions, again, move back to TRWD and they can provide additional guidance or direction on how to do that. So just briefly, we are trying to move most of our permitting activity, most of our review activity to a seller. The idea being that you can submit your documents online. It gives you a clear path on how to get through the process. There's workflows. It's structured for performing reviews. And so we're looking at shifting most of our work to a seller and building on the success that IPRC has already had with the infrastructure plan review work. We do plan to update our stormwater criteria manual in 2019. There's really just some refinements and clarifications we're looking to make to that. But if you have any feedback that you want to offer, then you can contact myself, Claire Davis, or send us an email at sds@fortworthtexas.gov, and we'll add that comment or that item to the list of things we're looking to address. Of all the possible updates, it's probably the local floodplain policy that we're currently working on that would have potential to make more substantial changes to that manual. You might have already heard, but the NOAA Atlas for Texas is now available. The rainfall intensities in our area really haven't changed. They're marginal at best, 1/10 of an inch here or there. It's really areas in Austin or the coast that have substantial changes to their 100-year rainfall depths. Stormwater works with a group that we refer to as a Stormwater Liaison Committee. It's made up of a handful of developers and engineers that work with developers. When we have concerns, questions, or we just want to bounce ideas off some people in the development community, we take things to them and discuss it. One of the things that came out of that committee maybe a year ago now was the idea of trying to find out what causes a review iteration. You know, we in Stormwater Development Services have been able to turn things around pretty quickly, typically within a 10-day goal, but then how many review iterations is appropriate? Is it 2? Is it 5? 5 seems high, maybe 2 is reasonable. But the idea was we want to focus in on reducing the number of iterations that we have. And so we worked with the liaison committee to come up with this idea of taking a sample of 20 ice-wind plan reviews. I guess it's actually a mix of final, preliminary, and construction plans. And we had 2 consultants look at these independently. One consultant was selected by the city, one consultant selected by the liaison committee group. And we evaluated these reviews, these projects, to try and figure out what caused that review iteration. Is there something we can do to change the way we're doing business to reduce the number of iterations? Ultimately, the idea is that we're saving time and money for both the community and ourselves. Of the sample 20 projects, each of these exceeded 3 review iterations. Most of the firms represented were people that we do business with almost on a daily basis. A few of them we don't see so often, and the one-time customers are probably folks from our town or our state. A summary of the findings from those 2 reports, which are available if anyone wants a copy. They found that in almost all projects, actually all projects, were affected by previous comments not being addressed. Almost all of the projects were missing data that would have been required to complete the review. And a little over half didn't meet our standards or had design errors on plans. That's just a graphical representation of the comments. Some of the comments fell into multiple categories out of those 14 categories. But as you can see, actually it's difficult to read on these screens. But most of the items were related to doesn't meet our standards or insufficient supporting data, things like that. And so where that's leading me to is our examples. But so you can see that about half the comments across all the reviews fell into doesn't comply with standards, and that's why I end up with the comment. I'll let you quickly read through that, but I think you get the idea. So with that in mind, we've prepared a series of design standard examples, things that we see most commonly. Almost every infrastructure plan set that comes in has comments that relate to these items. Erin's done a great job of putting these examples together for us. As our Stormwater Development Services liaison with IPRC, she's probably at most of the pre-sub meetings. So manhole locations are obviously important for access and maintenance. As design engineers, you're designing infrastructure that is ultimately handed over to the city, at least if you're working within the IPRC process. And so we need to make sure that we can access, clean, maintain, and operate the system moving forward. And so manhole locations are important to that. Something that's come up recently is concerns about manhole locations at the upstream end of the storm drain system. And there's been some debate over what constitutes access at the upstream end. Often an inlet is okay for a short run, but usually within 100 feet or 200 feet of that top inlet, there needs to be a manhole added. We do have, I guess, as a reference here to the criteria manual. But one of the reasons we want to make sure that the manholes are located appropriately to begin with means that we don't have to rework our hydraulic tables. Once you start adding those structures, you have to change your tables. And once you change your tables, that means you're coming back to your review engineer for a double check. And so if you can get that pretty close to right early on, it'll cut down the number of review iterations or compliance reviews. So you may or may not have seen some of our hydrojetting vac trucks around. This isn't exactly a Fort Worth truck, but you get the idea. We use the jetter hose, I guess a high pressure jetting head, to clean our lines. And the length of that hose is almost 300 feet. And so when you see that our maximum manhole spacing is 550 feet, that's because the hose can go up or down the line in both directions. And so that 550-foot maximum spacing gives us the ability to clean those lines. I haven't added to this presentation, but the ability to retrieve that hydrojet head is also tied to the Fort Worth's, what I've referred to, or people have referred to as being unusual, but our matching flow lines in our storm drain systems. And so by matching flow lines in our storm drain systems, it makes it a lot easier to retrieve the hydrojet head as well as the camera equipment. The guy on the left is actually a Fort Worth employee, and that's one of the inlet photos they took for us. I'm not quite sure how you get such large rocks and debris in there, but they use their equipment to flush that out. You can see it kind of, I guess, partially flushed out at the outfall of that pipe. So here you've got an inlet, and just a straight run down. And so they're able to move that hose, that jetting hose, through one 90-degree bend fairly easily. And so this worked. There's actually comments from our field op guys who helped us figure out on this one particular project what we can and cannot work with as far as access and maintenance goes. Even though these two inlets, I agree it's hard to see on these screens, even though there's a manhole at that location, their preference is to have the laterals come in an angle rather than 90 degrees. This is similar but slightly different. Our field ops provide feedback about this configuration and indicated that moving the jetting equipment through this bend here was more difficult, and therefore they would like to see a manhole at that location. So the point I'm trying to make is how you define a manhole being required at the top end of a system kind of depends on the design of that particular system. And again, it's tied to our ability to maintain, clean, and operate that storm drain. We also need a manhole located usually within the pavement, or certainly within 50 feet of the pavement, where we have an outfall that's difficult to reach. This is a good example where you've got probably a 20-foot drop to the flow line. That would also need to be a drop manhole to make that work, I think. On lateral slopes, we don't have a specific published criteria for this, but working with our field engineering and field operations, the upper limit is really 30% on your laterals, both from an access and a constructability standpoint. We did have one come in at 75%, and our field engineering guys told us they really couldn't even retrieve their camera equipment from that. Is that right? Yep. I hate to use the word pet peeve, but it might be one of mine. But the lateral connections, I think every single plant that I've seen first time, They come with a lateral connected at the center of the inlet. And I don't know if that's because it's easy to draft that way or that's just the way it makes sense to the designer. But City of Fort Worth inlets, our standard 10-foot inlet has 2 access openings, 1 at each end. And so the idea is that the lateral connection needs to be plumbed in, aligned with the access opening, so that when our field op guys are out there trying to get that jetter hose through, they've only got one vertical 90-degree bend to move through, and they don't have to get that hose through a vertical and then a horizontal 90. It makes it difficult to push the hose through and then retrieve it. And so, our standard inlets on new infrastructure is 10, 15, and 20. The manual does make reference to a 5-foot inlet. One of the reasons that the 5-foot inlet is in there is because it's not just development projects that use our manual. It's also used on CIP projects. The citywide, this is our stormwater criteria manual. Based on some analysis, some modeling, I think they actually used an InfoWorks model in Central Arlington Heights, they determined that all the street projects that were going in and rehabbing the pavement and adding 10-foot inlets instead of the 3 and 5-foot inlets that previously existed, that work was actually moving flooding problems around from one location to another. And so where there's an existing 5-foot inlet, the CIP projects are replacing them with, like in kind, another 5-foot inlet. And so rather than our capital project reviewers writing a variance for every street rehab project, we simply add that to the manual. But on a new development, simply in order to get our 2 access openings, there needs to be a 10-foot inlet as a minimum size. Just an example of trying to align the laterals with the access openings. It's a little difficult to see on the screen, but it's centered. And the reviewer in this case has provided a markup illustrating what we're looking to see. I guess this screen grab is from a erosion sediment control plan, but you get the idea. The laterals are approximately connected to the access opening. This is actually on my drive home. This is a 40-foot inlet. A 40-foot inlet's also not really a standard size. A little bit on lot grading. I won't go into too much detail. Maybe a year ago, Greg Simmons had led a conversation or a series of meetings about how we interpret our lot grading standards and how we're going to apply those moving forward. The findings of all those meetings were published in our April newsletter. But most of the contention was around having to provide a drainage facility in the middle of the block where you have a type B or type C that drains to the rear, and providing a drainage facility along the common property line. Our manual does define type B as breaking at the rear building line. That's also consistent with the original 1970s HUD guidelines. The main difference there is that house sizes and shapes have kind of changed in the last 50 years, and so that rear building line is actually a lot closer to the rear property line than what it used to be. Anything that's closer to the right-of-way, closer to the front building line, we really consider more of a quasi type C configuration, just because you have most of the impervious cover or the rooftop draining to the rear. So I guess this is an example of the kind of configuration we're talking about, but it's also an example of the contiguous lot lines. And so where we do have the break at the front property line, our standards require the contiguous lot line or the contiguous swale to move through. What we try to avoid is non-contiguous lot lines. By having them continuous, it's a lot easier to not have a rear drainage infrastructure, some sort of drain or swale, or maybe a swale that someone fills in over a few years. This is an example of the kind of plan sheet where we would be asking for a rear drainage infrastructure if you can't make the lot lines align. It's really about controlling runoff from the upstream neighbour and getting it down and through to the street in a way that the runoff doesn't have as much opportunity to go in someone's back door. This is an example even after we work with the engineer to correct it to the best of their ability. You can see lot 64 actually receives runoff from several lots around it. Previously, even these lots drained to the rear. When we first got this, there was about an acre of runoff to lot 64. Whoa. That's just an excerpt from our April newsletter. I won't read through that, but if you haven't got a copy, we'd be happy to provide it to you. And that's basically outlines a refinement to our lot grading standards, specifically with regards to when and where a rear drainage facility is required. The key to not having to do a rear drainage facility is really aligning your lot lines. I want to talk a little bit about erosion controls at outfalls. This is something that, again, on most plan sets that we see, the erosion at the culvert or the storm drain outfall is either too short, not provided, too narrow. It just doesn't really meet general design guidance. It's also important to evaluate your storm drain outfalls for more frequent events, not just the 100-year. Sometimes the 100-year tailwater masks the outlet velocity or the maximum outlet velocity. The ISWIM, the COGS ISWIM the hydraulics manual, provides specific guidance on the length and width of a riprap apron. I won't read through that for you, but it's out there and available as a design guide. It also provides some nomographs for you to determine the expected length and width of that apron. Some examples of why we might want to see those aprons appropriately sized. These are some of the plan. I guess it's an old plan set on the right, but it's a fairly new plan set on the left there. You've got riprap that's kind of just hanging in the air, and this one that seems very short for a 54-inch outfall, but also is drawn maybe not in the right spot. We've got a 54-inch line discharging, 8 square yards of riprap might not be adequate. You'd normally expect to see a length of apron 4 to 6 times the pipe diameter. Just as a general rule of thumb, you're probably looking at a D50 of around 8 to 12 inches, and of course, 1.5 times your D50 is your minimum depth or thickness. This is also something we see fairly regularly, is an outfall pointed at 90 degrees into a channel. If it's a narrow channel, you're likely to end up with erosion on the other side of the bank. And so if you haven't already shown your drawings, we're going to ask for that riprap apron to extend to the opposite bank. There is some guidance out there for how far from the opposing bank a storm drain outfall should be. I recognize it's maybe not easily to read on these slides, but this one here is about 10 times the pipe diameter as this dimension. Ideally, we would also angle the outfall in the direction of flow. This is a screen grab from our GIS, an example of a couple of outfalls into a creek, a FEMA-mapped floodplain, where they've outfalled well upstream of the main flow line and given that runoff for that stormwater a chance to slow down in the outfall channel first. Just, I guess, another reminder to consider tailwaters other than the 100-year storm when you're determining your velocity at your outfall. We grabbed this example of a temporary sediment control and outfall, just a bit of silt fence around the pipe. Silt fence is great when you've got a broad sheet flow, but when you've got concentrated discharge, silt fence is going to fail pretty quick. As you can see the photo of the rock check dam there in an outfall channel from a development. That's the kind of thing you'd normally want to propose or show at your outfalls. Silt fence is good. These are some silt fence retaining walls. They work hard, but they're not what you want to place in an outfall from a storm drain system. One of the reasons we harp just a little bit on erosion control is that erosion on your project site typically becomes sediment in the storm drain system downstream of your project, and either your contractor or the city is going to have to clean out that sediment. A few more photos of sediment accumulating at infalls to culverts. We also want to touch on placement of silt fence. On this project, they've placed their silt fence along the property boundaries, and that's pretty typical of a project, is to kind of delineate physically the boundaries of construction. But in this case, there was about 13 acres that drained to that point, and the silt fence actually created an obstruction. You know, we've had the wettest September on record, and October looks to be about the same. In a space of 6 weeks, we got 2/3 of our annual average rainfall. And so any flaws in drainage designs showed up pretty quickly, and then someone called the city about it. And so we went out there, and the silt fence had caused water to pond about a foot deep and then go through this person's property. They were pretty concerned that their house is going to flood. Actually, Aaron, can you hit play on that video? Yep. We couldn't make it at the site during the rain event, so the homeowner was quite happy to take a video for us. But you get the idea. It's actually also probably not a bad example of how to design subdivision, or maybe forgetting to pick up offsite areas, because there's about 13 acres drained to the property corner, and that's what the silt fence diverted onto his property. Thanks, Aaron. So you probably hear from us pretty regularly through your IPRC plan design that we need you to take your storm drain outfall to the flow line of the creek, or at least manage your runoff from your outfall to the receiving stream to make sure that there's really not a substantial erosion problem. This was a pretty good example, I think. The flow line's down here somewhere, the 100-year water surface is up here, and there's a cut embankment at 4:1. There's a good-sized riprap apron, about 20 feet long for a 27-inch storm drain. That's actually pretty decent. But once the runoff leaves that riprap apron, it's now accelerating down a 4:1 side slope. And so what we're looking for is to manage that erosion potential all the way to the flow line of the receiving stream, or all the way to the aqua outfall. This probably wouldn't work. It probably would look a little bit more like that after some period of time, either having eroded the downstream embankment or maybe the head wall's fallen off. One of the reasons we typically talk about taking your runoff to the flow lines because we have plenty of examples around the city where not managing that erosion control all the way to the flow line has caused infrastructure failure. It looks like they attempted to manage their erosion control to the flow line on the right. Maybe some curbs on that concrete apron would have helped. Just an example of the kinds of plans this is actually a good example. they've taken the outfall to a fairly flat grade to drain swale. It's probably not the best screen capture. It's a little small on this slide, but you can see they've taken a channel. They could have just outfalled, but they've actually taken a channel and directed it appropriately to the next pipe. And that way they've actually managed that flow fairly well to their outfall. This is a recent example that came up for us. We actually had complaints from this property owner here in red. So you can see, if we look at the contours for the existing condition, it's not a well-defined flow path, even though there's about 100 acres drained to this point. When they got done developing, you can see there's a fairly significant scar here where they've channelized it to the property line at a different location than where it used to outfall. The property owner was actually pretty reasonable about it all, and I think the development's working with them to resolve that. But just something to keep in mind, taking your concentrated flow to a concentrated outfall usually makes it easier. Just an example of some erosion that's occurred because the downstream system or the erosion potential wasn't managed. Similar sort of deal. The outfall was upstream of this, and you can see that in this picture, you really just have uncontrolled overtopping and then runoff. In aerial, you can imagine in pre-developed conditions, it was just a field. After development, they've installed their storm drain systems, they've collected it and concentrated and discharged on the field to the north, and that runoff has cut its own channel. This is an example of a project we worked with in the last few months. They only have flume conveying maybe 5 to 10 CFS, and rather than installing a storm drain system, they ended up using grouted rock riprap down the fairly steep embankment. But the point there is they've managed their erosion potential all the way to the flow line of the creek. With multi-barrel culverts or pipes, I just want to remind everyone that when you have multiple barrels, drop one of them just a little bit lower to match the flow line of the creek or whatever channel you're working in. It provides high velocities in low flow conditions and therefore less sediment accumulation. The higher level culverts also provide potential for wildlife. Don't laugh when I say this, but actually may provide wildlife access across major thoroughfares. So here's another bad example. You can see that the low flow arch is a little lower, and you've got your higher bank flood stage elevation for the other culverts or the other barrels. Another example. We have standard hydraulic tables for pipe calculations and for inlets. Make sure you use our standard tables. It makes it a lot easier for the reviewer to confirm you've met our standards. We're all used to looking at the same columns and the same tables and just checking for those particular thresholds or those particular errors we're used to finding. Usually if the hydraulic table has changed or if there's an error in the hydraulic tables, that IPRC review is typically kicked back to the reviewing engineer so that we can check the H&H calcs. And so if we can make sure our tables are in good shape moving into the infrastructure plan review, then that cuts down on the number of compliance reviews on the back end. We've just provided an example of a table that we received, I think on a first or second review, and all the values are blank. And so that almost automatically kicks them back to a compliance review. So our goal is to reduce the number of review iterations that we're all having to go through. That's it. Thanks for coming out. I appreciate it. Do you have any questions? All right.